this is the exam. For the first question, I'm saying that the racer wins is 2 because his velocity is higher than this person's towards the end, which means that his position is greater, which means he he went a further distance at time 10 seconds. This one is racer 2 is not accelerating at time 5 because it's a constant slope. Racer 1 has a positive velocity at time 5 because it's going upward. Racer 2 has a positive velocity at time 5 because it's not negative. They're still going that direction. And racer 2 is winning at time 5. Okay. Oops. The lighting's so bad. This is my position, and I did this by finding out the areas below each one and mapping it out. And then for acceleration, I took the slopes of those and placed them. Those are that's the key. Okay. The Newton's 3 laws are, the first one states that objects like to keep doing what they are doing. An object at rest, not moving, will stay at rest, while an object in motion will stay in motion unless acted on by an outside force. A ball will not move unless kicked or picked up and thrown. Simultaneously, in a frictionless space, friction is an outside source, which can and will cause a ball to stop moving when present. But when in a frictionless space, the ball will keep moving if thrown or kicked. Newton's second law states that acceleration is directly proportional to force and inversely proportional to the mass of the object, and that force is directly proportional to mass. My example is that a construction worker is pushing around 2 identical blocks of cement on a wagon. He wants the wagon's acceleration to increase by 2 times. He has 2 options. He can either remove 1 block so that the weight on it, the mass on it, is cut in half, or he can push the wagon with 2 times as much force. Newton's third law states that every action has an equal and opposite reaction. If I threw a ball at a wall, the ball would push back the same amount, but opposite because the ball would come back at me instead of going through the wall. Okay. They were asking how far Sally would go. So the first thing I did was find the hypotenuse of this, how much this is. And then I knew that I needed to find the force, the total force. And so I took the total force minus gravity. And so that's what this is. Yeah. And then, then I had to find the the acceleration. So then I just manipulated force equals mass times acceleration to find out the acceleration, which was 6.29. Then I plugged it in to this formula, which gave me velocity. Then I used that velocity to find both the velocity going horizontally and the velocity going vertically. if I wanted to find out y, I use this formula and I put this in. Then x, I put that in to be able to find the horizontal movement or displacement. And I got, like, moving here. Oh, it's the same thing. I wrote, I got 525 meters. Okay, here's my word. Yeah. So in the first scenario, I wanted to find the friction force. And so I knew that well, first I wrote all my free body diagrams to, like, just so I could get, like, see what was going on, or, like, attempt to see. Then I use mu k times the normal force to find the friction force. And I did that for each one. The friction force for scenario 1 between like kinetic between the two blocks was 29.4 newtons, and then between the block 3 and table 3, the friction force was 78.9 newtons. The friction force between T and 3, like, and the tension, I said in scenario 1 force at the force of static friction between blocks 2 and 3 is larger than the max force of tension between blocks 1 and 2. As a result, block 1 will never move. Consequently, blocks 2 and 3 can never move. So this would never. Yeah, that's impossible. It wasn't impossible in this, though. So after I used the same formulas to find, obviously, the friction force between 2, the kinetic friction between 2 and 3, and between table and block 3. But with the scenario 2 data, I'm like plugging them in, I found them, and then I wanted to find the forces, and I added those up so that I could find the acceleration, which is 9.10. And then I used this formula to figure out time, which is 0.075 seconds. So in scenario 2, it would take 0.075 seconds for block 2 to get to the edge of block 3. Also, I first had to convert like that. Okay, that's all. And that's 3. This is 4. No, I just did 4. Okay, 5. I knew I had to use the kinetic friction, and so I put that into this formula, which is mu k times mass times gravity, and that gave me 40 newtons. And so then I put that into force equals mass times acceleration, and since you gave us the kilogram, the mass, I put that in, and I had to divide to find the acceleration, which is -2. Because it's going in the opposite direction. And so then I put it into this formula, and then you gave it to us too, so that was just 16 squared, and I minus that over. Then I did 2 times -2, which is acceleration, and left, because we don't know d, that's what we're looking for. And then I divided by -4, like classic algebra, to get how many meters, and it was 4 meters. Okay.